Welcome to our channel Learning Math. In this video, we're going to learn about proportionality. One of the most important examples about proportionality is that of weight and mass for objects. As you see here, we have a table containing masses in kilogram and weights in Newton. Let's see what should be the value of weight over mass, which is Newton over per kilogram its unit. Well, if we have an object of mass 50 kilogram and weight 500 Newton, let's see weight over mass. Isn't it 500 over 50? If we simplify it, we get 10. The same here, 600 over 60. Isn't it 10? Also 750 over 75, it will be 10. If you note something, in all of these cases, we have the same ratio, which is 10. Well, same ratio, then we have a proportionality table. Here we can say that weight and mass are proportional to each other. In general, two variables x and y are said to be proportional if their ratio is constant. If we divide x over y, in all cases we will get the same answer, or if we divide y over x, in all cases we will get the same answer. So here the most important example for proportionality is that of weight and mass. We have weight over mass equal gravity equal 10 Newton per kilogram. Let's start by the first application. Here we have several values for x and y. If we divide in all of them x divided by y, 2.5 over 0.5. Shouldn't we get rid of the point? We multiply both by 10. We have one digit in each of them after the point. So here when we multiply it by 10 to move the point, we get 25 over 5. It gives us 5. The same here, x over y. So 20 over 4 gives us 5. Also here 30 divided by 6 gives us 5. So x over y is constant in all of these cases. It gave us the ratio, which is 5, the proportionality ratio. We say the ratio of the proportionality or proportionality constant is here 5. Another example, if we have a proportionality table or not, as you see in the first two cases we have them 1 over 2, while in the last one we have it 2. Why did we multiply here by 100? We have two digits in the decimal part. We look at the number either on numerator or denominator. Having more digits in the decimal part, we count these digits which are here 2. So we use 2 zeros and we multiply it by 100. As we multiplied here denominator, we should multiply the numerator. Now 0.7 times 100 gives us 70. Over 0.35 times 100 gives us 2. If you know something, 35, 70 over 35 is 2. If you know something, 1 over 2 in the first two ratios, while 2 in the last one, 2 is 2 over 1. It's the inverse of 1 over 2. They are completely different. That's why we say A over B is not constant, so this is not a proportionality ratio. Well, how to use the proportionality ratios if we have them proportionality tables? How to use them in order to determine the unknowns like A, B, and C. First of all, we have proportionality ratios, and we have same ratio in all cases. If we divide it like here, 0.014 over 0.07, we will get the answer 0.2. Well, what about A over 9? Sure, A over 9, we start by 0.014 over 0.07. So we start by it in the same method in all of the table. A over 9 equals B over 12 equals 16 over C equals 0.014 over 0.07, which gives us 0.2. Now, how to solve that? We start by each unknown alone. A over 9. Isn't it equal to 0.2? Now we write it. We move 9 here. Divided by becomes times. So A equals 0.2 times 9 gives us 1.8. Now we want to find B. We should follow the same strategy. B over 12 is equal to 0.2. Now we just move 12 from the denominator, divided by becomes times. So B equals 0.2 times 12 equals 2.4. Well, here 16 over C equals 0.2. We move C here, divided by becomes times. So 16 equals 0.2 times C. Now we want to find C. We move 0.2 to the denominator. So C equals 16 over 0.2, since times becomes divided by, is equal to 80. Something which is very important, to make a cake we should follow the directions. We use 75 gram of flour, 40 gram of butter, and 3 eggs. Well, what directions should we follow in order to bake 2 cakes together? Well, if we want 2 of them, so we multiply our indications by 2. 100 times 2 gives us 200. As you see here, we should multiply them by 2. 40 times 2 gives us 80 gram. Also 3 times 2 gives us 6 eggs. Now something which is very important in proportionality. If we have, for example, 10 over 15, let's simplify it by 5. Shouldn't we get 2 over 3? Well, here we can say that 10 over 15 is proportional to 2 over 3. What happens if we reverse the fractions? Well, how to reverse them? We can say that 10 over 2 equals 15 over 3. Let's see if they are equal or not. If we divide 10 by 2, shouldn't it give us 5? Also 15 divided by 3, it gives us 5. Same ratio, so they are still proportional. Here we conclude that if we have A over B equals C over D, we can directly say that A over C equals B over D. As you see here, A over C equals B over D. Well, the same if we reverse the fractions. Look at them, please. 15 over 10 and 3 over 2. Let's see, are they equal or not? We have 15 over 10. Can't we divide them by 5 to simplify both of them? They are simplified by 5 to give us 3 over 2. Isn't it the same ratio as the first one? It's reversed. Why? Here it was 2 over 3. Its inverse now is 3 over 2. We have reversed the first fraction, so we should reverse the second one. So we can say that A over B equals C over D, then B over A equals D over C. If we reverse the first, we should reverse the second one. Something else which is very important. Note please, we have 10 over 15 equals 2 over 3. If we add numerators together, can't we say 10 plus 2 equals, over 15 plus 3 equal to them? Let's check it out. 10 plus 2 is 12. 15 plus 3 is 18. Can't we simplify both of them by 6? What should be the answer now? 2 over 3. We have the same ratio, which is a proportionality ratio. Here we're going to learn a rule which is very important. A over B equals C over D. It will be equal to A plus C over B plus D. Let's move to percentage and proportionality. Sure, in order to transform a fraction or a decimal number into a percentage, we just multiply it by 100%. Here are some examples. If we transform 0.3 into percentage, we just multiply it by 100%. Now we move the point by 2 digits since we are having 2 zeros. So it will be 30%. Sure, we fill the empty spaces by 0. Here the same. 9 over 50 times 100%. Can't we simplify 100 over 50 is 2? Now 9 times 2 gives us 18%. The same for 7 over 9. 7 over 10, we multiply it by 100%. We can simplify 0 by 0 to get it as 70%. Now for decimal numbers, we have just learned that we multiply them by 100%. So we move the point here by 2 digits since we are having 2 zeros. 1, 2. The point will be between 3 and 5. Another example. In a class of 20 students, there are 7 boys. What is the percentage of girls? This is very important. Well, we have a class of 20 students. Aren't the girls 20 minus 7, which is the number of boys here? So 20 minus 7, it will give us the number of girls. It's 13. How to transform it into percentage? They are 13 girls out of how many students? Out of 20. So we say that it's 13 out of 20 times 100%. It gives us 65%. Another method, you can say that 20 students give us 100%. 18 students give us x equals how much? Well, finally, an activity, if we have 30% of 150 students are footballers. What is the number of non-footballers? As you see, we have a hint. We have 150 students. 30% of them are footballers. We want the non-footballers. How to solve it? First of all, since we are dealing with percentage, we should know the percentage of non-footballers, which is 100%, the total percentage, minus 30%. It will give us 70%. Well, the number of non-footballers, isn't it 70% out of 150 students? So we can say that the number of non-footballers is 70 over 100 times 150. Now we can simplify 0 by 0. Also here 0 by 0 to get it 7 times 15, which is 105. So from the percentage of footballers, we got the percentage of non-footballers, which is 100% minus 30%, 70%. And from the percentage of non-footballers, we can directly get the number of non-footballers. So it's 70 out of 100 times 150. Here's something which is very important. We can deduce the number of footballers by two methods. We can either say they are 30% of 150 students, means 30 over 100 out of 150, so times 150 to get 45. Or we can say the number of footballers is 150, the total number, minus 105, which is the number of non-footballers, to get it 45. Thank you for watching. If you enjoyed this video, please like, share and subscribe.